Hello and welcome back to Ganesh Institute and in this series of linear algebra. So today we are taking up another topic from matrices and that is rank of a matrix. We will learn what is the rank of matrix and what are the ways through which we can find out the rank of a matrix. For instance, higher order minors or the normal form. So we will also explore what is a normal form and how it can lead to the rank of a matrix. So let's get started.
What is a rank of a matrix? Basically, there are many definitions when you define a rank of a matrix. So let's start with the basic one. Let's say you have a matrix 1, 2, 3, 2, 3, 5, 3, 4, 7. Now what you need to do, you have to create minors out of this matrix. How many minors? If I ask you highest order minor, the highest order minor from this matrix, because this is a 3 by 3 order matrix. So of course that highest order minor will be equal to third order minor. Correct. Now third order minor, how do we calculate it? So we need to simply find out what? The determinant. So if we find out determinant, then we need to take 7 3s are 21 minus 5 4s are 20 minus 2, right? So we need to hide row and column. 7 2s are 14 minus 4 3s are 12 plus 3. 5 2s are 10 minus 9. So what have you got? 1. 14 minus 12 is 2. 2 2s are 4. 10 minus 9 is 1. 3 1s are 3. 4 minus 4 is 0. Because the determinant comes out as 0, so we will say that no, we cannot say that rank of the matrix will be of order 3. We need to go for a smaller order. So let's say we have second order minor. Now how do we calculate second order minor? See, from this matrix, you can take any of the second order minor. This is 1. This is 1. Right? Any 2 by 2 order matrix, a sub matrix which you can form out of it. This one is the possibility, this one is the possibility. You can take any of these and find out whether the determinant is 0 or not. So if I take 1 2 2 3, okay, the first one, 1 2 2 3, these 4 elements. So I have taken second order minor. Now find out the determinant. So it will be 3 1s are 3 minus 4, right? Cross 3 1s are 3 minus 2 2s are 4 minus 1, which is not equal to 0. So that means we can say that rank of the matrix is of second order. So one definition to find out the rank is that you need to find out the minor. So we will say a number R is said to be a rank if it has two properties. If it follows two properties. Firstly, determinant of at least one minor. If you find out the minor and at least one minor is non-zero. The determinant of at least one minor should not be 0. And secondly, the determinant of every minor, every single minor, be it 3 by 3, 2 by 2. Okay, the determinant of every minor of order higher than R, remember, higher than R, has to be 0. For example, here we have got rank as 2 because if we take any number higher than R, let's say 3. R is 2, 3 is greater. So what we were getting? Determinant at R is equals to 3 is 0, correct? So that means any higher order minor. Higher means what? Greater than the value of R should get the determinant as 0. So these are two conditions when it comes to rank of the matrix using minor. Now this is not the only option which you can follow. Another one is normal form. Okay. So what do we do in normal form? Basically, there are a series, you can say there is a series of steps. You can apply elementary row transformation, or what is it called? Gauss-Jordan. You need to apply elementary row or column transformation. Okay? Now, you need to basically reduce a particular matrix into normal form. What do you mean by normal form? It may be anything. IR, so identity matrix into R. R is the rank. Or any matrix of this form, then we will say that R is the rank. It can be in the row form or column form, then also it is a normal form. Or we can have the last possibility that we are getting triangular or echelon form. Maybe we are getting upper triangular or lower triangular matrix in this form. Then also we will say that this is the rank, normal form. Okay. How would you do it? How will you find out the normal form? So there are a few steps. Firstly, you can interchange rows or columns to obtain a non-zero element in first row. For example, if you have a matrix -2, 1, 1, 0, -1, 2, 0, 1, -3, 3, 1, 1, -1, -1, 1, -1. This is the matrix given to you. You need to find out the rank by normal form. By normal form. You could have applied minor fact as well, which we did earlier. But here question is specifically asking for the normal form. So first step is you need to interchange rows or columns if there is a 0. But it is not the case. So let's move to the next step. If this non-zero element is not 1, you have to make it 1. Just like we did it, we do in identity matrix form. You need to make this 1. How can we do it? Can we simply interchange R1 and R2? Because R2 is already having 1. So I am interchanging 1, 2, 3, -1. This has become R1 now. And the first row has become R2. Rest, everything is as same as we are having it. Okay. So this is now your matrix. Now what is the next step? You need to obtain zeros in the remainder of first row and first column. Try to make rest all of the elements in the row and column as 0. You need to make them zeros. How can you do it? See, we have already got 1. So it is easy to make 0. How? If I apply, this is -2. If I have to make it 0, what can I do? I can add 2. That means R2 plus 2R1. Similarly, this is 1. If I just subtract R3, if I take away R1 from R3, make sure this is the base which you have already formed. So now your matrix has become what? You are not changing anything in R1. So R2 minus 2 plus 2R1, which is 1. This is 0. R2 minus 1 plus 2R2. 4 minus 1 is 3. Then minus 3 plus 2R1. 3 to the 6 minus 3, 3. Then minus 1 plus 2, 1's a 2. Minus 3. Right? This is what have you got in R2. Now you need to make R3. So R3 will be R3 minus R1. 1 minus 1, 0. 0 minus 2, minus 2. 1 minus 3, minus 2. 1 minus minus plus 1, 2. And then the last row you are not changing anything. Correct? So this is your new A. Now what you have to do in it? You have created all these as zeros and this as one pivot element. Now similarly, make these three as, by using column transformation, make these three as zeros. So again you have here base element as 1. So what you can do, if you subtract from C2 to C1, from C3, 3C1, and you add, this is 4, C1 into C4, correct? You will get zeros. Let's try. So we are not doing anything in C1 because we have got what we wanted. C2 minus 2C1. C2 minus 2C1. Let's do rough work here. 2, this is C2 minus 2C1. So 2 minus 2, 0. Then C2, 3 minus C2. C2 is 3. This one is 3. And then minus 2C1, which is 0. So these are going to be same because all rest elements are zeros. Then we have C3 minus 3C1. C3 minus 3C1. So 3 minus 3 is 0. Actually, we wanted 0 only. That's why we applied these transformations. So these are 0. We are going to get zeros only. Okay. Now, what is there? We have here C3 minus 3C1. Where is C3? Here. C3 minus 3C1. Again, C1, rest of the elements are zeros. So C3 is the, C3 will remain C3 only. Then C4 plus C1. C4 is here. C4 plus C1. Again, rest all the elements are. Okay. So you have got what? You have got rest 3 elements as 0. Now you have to keep doing in this manner. Just make sure that the leading element, leading diagonal, you have to make 1. Rest all elements, if you can create 0, then it's fine. And we specifically want any of those normal forms. Okay. Be it simply all the non-zero elements, or if we have rows and columns, then only one non-zero element, rest all have to be 0. And if it is higher order matrix, 2 by 2, 3 by 3, then we want echelon form, triangular matrix. See, these are zeros, or it can be upper triangular, lower triangular. Okay. So let's try to make this. We have got these 3 as zeros, these 3 as zeros. Let's move on to the next step. What can we do to have more zeros? Can I apply? If I do R3 plus 2R2. R3 plus 2R2. What would you get? First of all, let's have 1 here. How can I have 1? If I interchange R4 with R2, correct? Okay, I'm not changing R1. R2, in place of R2, it has to be R4. Okay, and R3, we are not changing anything. And in place of R4, it has to be R2. Correct? Now we have got these two elements 1. I need to make these two and these two as zeros, right? How can I do? Once 1 is made, it is easy, right? Let's apply in row transformation. So R3. Can I do R3 plus 2R2? Because minus 2 plus 2, it will become 0. Then for R3, if I take away 3R2, this is my base 1. Now I'll get zeros. So I'm not changing anything in R1. In R2, this is R4, right? R4 tends to R4 minus 3R2, right? Okay, let's do it. So I'm not changing anything in R2 as well. In R3, what I'm doing? R3, let's do rough work here. R3 plus 2R2. So it is 0. R3 plus 2R2. Again 0. R3 plus 2R2. So 2 minus 2 again 0. Right? In R4, what I'm doing? In R4, I'm having R4 minus 3R2. So 3 minus 3R2. 0. R4 minus 3R2. 0. R4 minus 3R2. Minus 3 plus 3. 0. Wow. We've got whole rows. 2 rows as, 0 rows. Now what you are supposed to do, just try to, you have to keep doing this, continue the process down the main diagonal until the end of the diagonal is reached or all the elements become 0. Then whenever you have to find out rank, you can say those which are non-zero, those rows which are having non-zero elements, you count them and that will become your rank. For instance, you have, is there any chance that you can create more zeros? Firstly, find out. So this is 1, this is 1. Can you create more number of zeros? Otherwise, you can simply say these two are non-zero rows. They have some non-zero elements. So number 1, 2. 2 is the rank. But let's try if we can create more number of zeros. How can we do so? Okay, I need to make these two also. I have only applied row transformation. What about column? We need to apply column as well, right? So C3, if we take away C2 from C3, and then from C4, if I add C2, this is my base 1, correct? So what will I get? My matrix becomes, so I'm not applying anything in C1, neither in C2. C3 minus C2. 0 minus 0, 1 minus 1, 0, 0 minus 0, 0 minus 0. Wow. This has become 0. Now C4 plus C2. 0 minus 1 plus 1, 0, 0, 0. Great. So if you see, if we divide them into submetrics of lesser order, we will see we have only one matrix. What is it? Identity matrix, right? So only two rows are here which are having pivot elements, or we can say non-zero number. So 2 will become the rank of the matrix in the normal form. Because ideally what we wanted the matrix to be either in this form, in the row form, in the column form, or rest all elements have to be 0. Only the identity matrix have to be formed, and we need to check how many non-zero elements are here. Okay, so non-zero elements 2, hence rank of the matrix is also 2. There is another concept also to find out the rank using Euclidean form or linear combination, which we will discuss in the rest of the videos. Okay, hope you have got it.
If you really like this video, then don't forget to like, share and subscribe our channel. Till my next video, take care of yourself. Bye-bye.